Welcome back. This is an Aleks training video on predicting the relative lattice energy of binary ionic compounds. A lattice is like if you have ever seen lattice under someone's porch, it kind of looks like, this. This is lattice work. All right, so a lattice is a network where things are repeating. And so the lattice they're talking about here would be like an ionic bond where you have something like I'm bad at drawing. Let's try this. So you've got something like that. And you're seeing this three-dimensionally. So these guys would be maybe negatives. These would be positives. And they kind of fit together like marbles in a box, kind of in a very, very tight fit. Okay, so they're attracting to each other. So you've got bonds together between positives and negatives here, between positives and negatives here, between positives and negatives here, and so you're getting a lattice. You can kind of see that you've got like a grid work, and it's three-dimensional grid work like monkey bars are. Okay, so the energy, a lattice energy, is the energy that's pulling this crystal together and making it nice and tight. So some crystals are very tight, some are very loose, some are very stable, some are very unstable. So if you can get negatives and positives next to each other, that's going to be pretty stable. Also, you want it to be close together. You're going to use Coulomb's law, which we learned in physics. And Coulomb's law, the force of attraction, because we want to know the energy. So that's the force of attraction that's making it, the energy pulling it together. Okay, so what is that force? It's going to be equal to some kind of a constant times the magnitude of the first charge, let's say the positive charge, and times the magnitude of the second charge. So let's just call that the positive charge and the negative charge, divided by the square of the distance. So if you want them very, very close together, you'll get a bigger lattice energy. If they're farther away from each other, you're going to get a lower lattice energy. Also, if your charges are bigger, let's say you have a positive 2 charge times a positive 1 charge. Well, that would be a bigger force than two positive and a negative 1. So if the number, so let's say if Q can be bigger, then your force can be bigger. And if R can be smaller, your force can be bigger, since it's on the bottom. Okay, so you're given 2 and asked which one has the highest lattice energy. Well, the one with the highest lattice energy has the smaller R, okay, the smaller distance apart, and it has the largest charge. Okay, so you're like, okay, how do I know the distances? The distances are how big that atom is, or that ion is. Okay, so you remember atomic sizes as you go down the periodic table, the atomic size, as you go down, it's going to increase. Okay, and as you go, over, you're going to increase. Okay, so you want the smallest possible size. Okay, so the smallest possible size would be towards the top. Okay, towards the top and towards the left. I think that's right. All right, so let's look at the questions and see what we can do. Which compound has the bigger lattice energy? All right, so the first one they're looking at is cesium plus iodine and cesium plus bromine. Okay. Well, bromine is above iodine on the periodic table. It's 1 above it. Okay, so that means that bromine is smaller, and if smaller means the R is smaller, and if the R is smaller, then the force is bigger. Do you see that logic? The smaller atom would pull more because it's closer together, right? So the CR would have the bigger lattice energy. Okay. What about the K2S and KCl? Okay, KCl and K2S. Well, Cl is bigger. I'm looking at periodic table. I should probably put it in. Okay. Cl and S are on the same row, same period, but Cl is more towards the right and S is more towards the left. Okay. So, but I also see that there's two Ks. There's two Ks and only one K in the, there's two Ks with the sulfur and one K with the chlorine. Okay. So the chlorine has a charge of -1, the sulfur has a charge of -2, so that's a bigger Q. Okay, so that's going to give K2S the bigger energy. And then the last one is the magnesium and fluorine and the sodium and fluorine. Okay. Well, magnesium has a charge of 2 and sodium has a charge of 1. So the magnesium has a bigger Q, and so it's going to have a bigger F, and that's what they're asking for. Which one is bigger? Which is the lattice energy bigger? Okay. I think you can get this. I think you can get this.